Alright, so I'm working on this leakage tester, and I'm actually at a point where I'm thinking I might revise the design again. Maybe. I think it might be what I want to do for me rather than for my configuration. I think it might be a better option as well for other people, but I think I'm just going to leave the board intact as it is, because that still gives options about how you can configure it, how you can build it up. It gives you all these different ways you can do it, and being something that's going to be shared, I want to make sure everyone can do it easily. What I'm referring to here is that I've got this multiplier here. Obviously I've taken a couple of caps out because I don't need them anyway, I'm not using them. With this big cap here, that effectively actually acts like part of this multiplier circuitry, because it's actually across the output, so actually even if I've taken those other caps out, it still doubles. Anyway, but that's a 22 UF cap and it's DC, so it's working quite nicely. So I'm getting a good voltage from that. I'm getting around 400 volts, 440 volts I think in this configuration. Feeding 230 volts in. Actually I'm getting about 220 volts because this transformer is not very efficient. It's losing a lot. Maybe I've actually got it backwards. It might be that this is supposed to be the primary and that's supposed to be the secondary. I think that might be the case. So I'm getting about 220 volts going in. I'm getting about 440 volts coming out or so, which is being clamped by the diodes here to limit it. Alright, so that's all working. So it does work, but the current is limited a little bit to sort of like 20 milliamps or so max. So if you've got a big cap, it takes a little while to charge up, makes it a little bit slow. Not a big deal. It's probably fine. So I think I'm going to leave that as it is. So if people want to use that part, they can, and do this kind of design. You've got a main transformer acting as an isolation transformer. If you need to double it twice, you can do. If you've got 115 volt supply in, you can use both hits and multipliers and get that same kind of voltage, but at an even lower current. What I'm recommending now, I had these originally set at 1 UF because that's the caps I happen to have, and they were cheap-ish for what they are. Still fairly expensive, but when I took those caps out, I actually stuck them on the back of the board underneath these ones, so they piggybacked. So that was, instead of being 1 UF, it became 2 UF. And that actually increased the current carrying capacity. It doubled it basically, right? So that was a good thing to do, because now I know that these cap values aren't really right. So it probably needs at least 2 UF minimum, maybe more. So, but as big as you can fit in here, you know, any caps, as long as it's an AC rated cap, which is capable of carrying the voltage you're shoving through it, the bigger the value, the better, right? Then we'll get more current out of the unit. So that's a little design note. I did have a weird issue where when I was probing the AC line here, the LCD display would crap out. Must be picking up some noise. I chucked some ferrites on here, just on the actual output leads here, and on the leads going to the display. I've wrapped it around a couple of times around that one, and the problem's gone away. So it's obviously some induced noise in that circuitry, and it's just radiating a little bit or something, getting into the power leads maybe. Anyway, it's okay now. That problem's gone away. I forgot to allow for on the circuit design was the switch, right? What I've had to do is I've actually lifted the resistor that's in there, which goes across here. I've lifted it up, stood it upright, and that then runs through to the switch. Because what I was actually not allowing for was the fact that as I'm measuring 2 voltage points now, I couldn't have the switch after the board, otherwise you're measuring the same voltage at that point. So I had to break into that line just there by lifting that resistor up. So I've actually done another board revision, so that'll be the one that actually gets published in the end. So I've done another revision which has allowed for that resistor there and a couple of little things like that as well. Also I made a mistake on the pulled layout. On this version here there's no link between those 2 diodes. For some reason the track's not there. I somehow missed it, but it wasn't there. So I had to put a link on the back of the board to link those 2 diodes there together. So there's only like a couple of little errors on there. And that voltage adjust resistor I've got down there, it's a 1K. I'm debating that value. I can actually see it's been stressed. It's already discoloured slightly. So that's only a quarter watt resistor though, so if I up that to a bigger wattage resistor it should be okay. I'm not too worried about the rest of it. I think the rest of it's okay. I've been tweaking the layout slightly just to allow for moving things around and adding it. So also on this switch here, I've got a resistor across the back of the switch. It's in heat shrink, you probably can't really see it in there. That is a drain resistor, so that is there to discharge a capacitor when it's when the switch is in the off position. Now, with the switch you've got a couple of options the way you can do it. I've used a momentary switch, so it's off and momentary on, right down the bottom. So it's always up, and you push it down to activate it. That's purely for safety, so you can't accidentally leave it latched on and have high voltage going through from the leads. Alright, purely a safety aspect. You could use a double momentary, like center off switch, so center off and momentary up, momentary down. So center off would be like a neutral position, nothing, no power going to it, no draining coming out. Down could be momentary on, and up could be drain. So you manually drain the capacitor. It might be a good way of just checking the voltage on the cap after it's been charged and just see how the cap responds. It's a consideration for the design. So if you actually want to do that in the end, then maybe that's something you should do, is actually make that a double momentary switch, central off type. So as I was saying about the high voltage stuff, now this works, but it could be better. And you know, you've got this 12 volt supply here, well it's actually about 11.3 is coming out of it. I've got that transformer there, there's all this complication here. Thinking, well, yes, it works, but you can buy these high voltage modules. I purchased these a little while ago, they only arrived a couple of days ago. And both of these modules didn't work when I got them. They were both faulty. They were both damaged in the post. Typical. The capacitors are in it were squashed. Yeah, look at that. It's just so they're shorting out. I don't even see it on camera there actually, but the tops were squashed in. Right, it's just no good. I managed to get them both working in the end. Bit of a pain, but I've got them both working now. And what you do, you basically shove a 12 volt supply in here. You need at least 12 volts. I've had it running up to like 31 volts, and it seemed to be fine. The higher the voltage going in, the more current it could put out. About 13 volts seemed ample. 12 volts was pretty good. It worked on 11, but it worked better at 12. So I'd say 12 volts like the minimum what you want to put into it. And you've got a little adjustment on there, so you can adjust the voltage up and down. So the maximum it does is about 390 volts or so was the maximum it would put out. Minimum is about 41. So you can adjust it right up and down with that. You can actually use this as a supply, and in fact you can run off 12 volts. Means what you can actually do is not need that transformer. That saves you a bit of money. You don't need that transformer. That also saves you a bit of money. You don't need that power supply board. What you would need is a 12 volt input on the back to run off a bit of lag gear or benchtop supply, or you could even build one of these in. Right, this is a 12 volt DIN rail supply that will actually just fit in this case. If I didn't have that big main socket there, I think it will just fit. It might even squeeze in there. All right, so that's a 12 volt supply. You could use that. You can get physically smaller ones, but this one's rated 3.5 amps, which means it's got some leeway there for the current draws and surges and stuff like that. You don't want to stress it too much. So you could use one of those, and that could power the electronics and the high voltage supply at the same time. And then you could have either 12 volts coming in, running it all off 12 volts, or between 12 and say 30 volts, because the regulator here can handle about 32 volts, I think. I'd keep it below that though. Wouldn't want to push it too much. So you can have that wide range. You can run it off 24 volts if you wanted, whatever, it'd be fine. And they could both handle it. Or you still might keep mains, but you run your own internal power supply. I've got a 12 volt and a 24 volt version of this. I've got both exactly the same size, same wattage rating, stuff like that. So there's options out there, different ways you could do it. And I was thinking, well, that's actually a better way of doing it. But the problem is, this I'm trying to make as a project for other people to build. It relies on them being able to get a high voltage power supply like this. One of its high voltage modules. This is something you have to buy as a unit. They're easy enough to get, but I don't like to rely on other people's stuff if I'm making a project. I'd rather have it built from scratch. A transformer, if you can't get that exact transformer, it doesn't matter, it's just a transformer, right? These caps, it doesn't matter, they're just caps. The Arduino Pro Mini, well, they're common as muck and they're really easy to get. It's not a problem, You could buy 20 today for, probably $10 or something. It's nothing. But these are a bit more specialised, and I'm worried about, you can get them now, but what if you can't get them in 6 months' time? Now, I've actually got two versions. This one does better. This is another version I bought as well, which has actually got a voltage multiplier on it as well. But that's tiny little caps. This only puts out a couple of milliamps though. It's really weak. It'll be good for some things, I'm sure, but it's not suitable for this particular project. It just doesn't put out enough power. Obviously I've tried it, but it does a couple of milliamps. Voltage wise, it does a lot. It can do 1,000 volts, right? I had it doing 1,000 volts. I think that's a 12 volts input or something. It actually worked with 5 volt, but again, if you increase the voltage slightly, it worked a lot better. But it can't handle a lot of current. It's a very low current supply. But if you need something which can put out a lot of voltage with a low current, that's not a bad option. But it will dip a lot. As soon as you put a load on it, it will drop right off. It's one of those things you have to be super careful of. So it's not suitable for this. But these ones work well. These actually work better than the original supply. This supply I've got in here, this beats it. When I doubled those capacitors up to make them 2 UF, they were closer to what this could do. Still not quite the same. I've actually got some notes here. when I loaded the output with a 10k resistor, with a 2 UF capacitor in here, in these two stages here, when at that stage, I could draw 20 milliamps. I was getting 190 volts on the outputs and 300 volts on the supply rail. If I only had the 1 UF caps in here, I could only do 13 milliamps, and I was getting 130 volts on the output, 210 volts on the supply rail. So it's quite a significant increase just by going from 1 UF to 2 UF. Now, using this thing, that would generate 22 milliamps. I was getting 220 volts on the outputs and 340 volts on the supply rail. So this actually does slightly better. Not bad. And that's just in the test condition I was using. The resistor values I was using as a load. The resistor values I've got in here. Also, I changed that resistor there, which I had as a 10k. I've changed it to a 5k. And I've also beefed it up to be a 1 watt resistor. The reason being is it was actually, when I was doing this testing, that resistor started to overheat. And it was just too much for it. So I've reduced the value and increased the wattage to stop that happening. So I can take a longer load, a bigger load for longer. The other issue I have is the voltage adjustments. So like this one here is one I was playing around before. This is the original one I had on the case. Now they work, but when we've got 400 odd volts across them, they get a bit warm, and that's a little bit concerning. I'm not sure what to do about that part yet. I may make it switchable, so when you only use high voltage when you need to use a high voltage, just to be safe too. I might make it say 200 volts or 400 volts, high-low range or something like that. Another consideration is on these modules, they have an adjustment, right? So if you used a module like this, which has got an adjustable pot on it, you could take that pot off, run the wires to a controller on the front panel, and use that to adjust the voltage from the high voltage supply, and not have any of this stuff, right? You wouldn't have that connection there. Then you just run it straight off that module. Is that a good thing or a bad thing? I don't know. It relies again on a module and being able to modify it to suit the unit, right? Being able to take the pot off, assuming it has the pot, and hook it into the unit. Now the minimum voltage I can get out of this, I think is about 45 volts is the lowest it would go down to. So if you're trying to do a cap, which is a 20 volt cap, or 25 volt cap, or 16 volt cap, that's too high for it. But I was looking at this, and there's some serious resistors just here. That's across the outputs somehow. I can't remember exactly how it goes now, but it's sensing that level there, and it's feeding back, and that's adjusting that feedback level, which is what's controlling it. It might be a case of being able to reduce these resistor values on here, which will then allow you to go to a lower range, but that might limit the upper range. Don't know, but this little module works alright. It's okay if they're not broken when you get them. So there's my thoughts on that right now. What I've designed works. It doesn't do big currents, it's only low current, right? So it can't do 20 milliamps happily. That's the bit I'm looking at right now, and the fact I'm now having to use 220 volt input into this in order to get the voltage I want, that's the other thing I'm not happy with as well, because I wanted to do it with 115 volts input. The fact that I've now had to modify that input option as well means I'm also not happy about that. So I'm kind of on the fence now which way to go. I could carry on with what I've got, make that work. I mean, it does work. I've already had the thing working, right? It does its thing. Or I could put in one of these modules, which makes it work twice as well. Better stability, higher current handling, but requires 12 volts also, right? Which means I then have to rejig this, which means that transformer will go, and that transformer can go, and I can shove this in there instead, right? As I said before, I could do that, and that will work, and that's actually a nice, tidy-ish way of doing it. But as I want to release this project, it may not be easy for everyone to do it that way. I'd like to hear some thoughts. On these modules. If you're going to build this project, you're going to need these modules. Do I buy a bunch of them and resell them? Is that something I should do? Or buy a bunch of them, fix them, and then resell them, as the case has been with these things. Now, so I'm a bit of a crossroads here. I don't know which direction to take with it. That works, but the current handling is not great. If I upgrade these capacitors, it works better. I'm happy with that. And I'm still not happy with the fact I'm running off 220 volts, so not 115 volts. That's the bit I'm not happy with. This voltage multiplier doesn't work as well as I want it to. I'm going to change these caps. I'm going to buy some more caps, I think, and change these caps to some better ones, or higher capacity ones. The thing is, though, those caps are more expensive than buying one of these. One of these modules is, what was that? I think it's about $5 New Zealand. So it's about $3 or $4 US or something for that whole module. Well, I'm paying that much for one of those capacitors. Alright, so if you look at the cost aspect, most people have got a 12 volt power supply, which can do an amp or two, right? A couple of amps. Not a problem, most people have got those. If you don't have one, they're easy to get. Transformer, that is about, I think that's about $40, $50, something like that. These caps, you've got $20 worth of capacitors. It's like $60 for those. That transformer there is about $10. So you're talking $70 just for the power supply aspect in here. $70. Well, that's $5. And some power supply you could even use a plug pack sort of thing, like a little laptop power supply or something like, those little 12 volt ones, 12 volt bricks. They're cheap. You can get one for like $10, $15. So for a third of the cost of the power supply, you could do it this way. This unit, I think that costs about $30. This thing here, something like that. So that's a Meanwhile one that actually worked quite well. They're called the good brand. So yeah, I mean, it's like that way is more expensive, but more accessible to people. Okay, more expensive but more accessible. Apart from the voltages, and this stuff is cheaper, but harder to find. Which is better. I mean, if it's just for me only for me, I'll be using this. That's what I'll be using. But because I'm doing it for other people too, I need to make it accessible. Right, so I'm going to try something here. Now, I'm not happy with this whole high voltage and high current going through this pot on here. Although it kind of handles it, it's not the best. Right, it's putting a bit of stress on. It's getting a big voltage drop through it and that sort of stuff. Because I'm not actually happy with that, I decided I'm going to try something. Now, one of the ideas I had was to use a MOSFET to control the voltage instead of doing a pot to do it. So I've put together a little MOSFET circuit. I found a little MOSFET circuit online. It's basically high current, high voltage MOSFET. It's supposed to be handle up to 500 volts anyway. And it's these things here which I purchased previously. TK5A50D. Alright. These are high voltage MOSFETs. So I've got one in here. I've got a little circuit built up here which is based on something I found online, which in theory will probably work fine. It's a pretty simple little circuit. And it should basically regulate itself and things like that as well. Over here is a pot, which will hopefully work. Although it's not exactly the best, I might need to look at how I do that. Just better find my meter up. I need to make sure that thing doesn't come live before I touch it, just in case. And I want to be safe with that rather than sorry. Stick a lead on there for grounding. Check the voltage. Right. Okay, well, let's fire it up and see what's going to happen. It could go bang. It could work. I have no idea. I haven't powered this up yet. This is powering up for the first time. But the first thing I'm going to do is make sure this isn't going live before I touch any of it. Alright, ready? Well, hasn't gone bang yet. And it's showing 53 volts. Ooh, does that mean it's working? Okay, let's check for any live on here. Yeah, 135 millivolts, that seems fine. I'm still going to be awfully cautious about it though. Well, it's turning down, it's reducing. So I'll do that. Okay. What about turning up? That is all the way up, 53 volts. Yeah. Nah, that's not good enough. It is adjusting and it's working, but the voltage is obviously nowhere near high enough. So I need to look at how I adjust that gate voltage on there. Obviously it's not adequate for what it's doing. So the circuit I've got is using a 470k resistor here, which is a feedback from the pot. So let's measure the resistance, the voltage at that point, what we're getting. 50 volts AC, 393 volts DC, 434 volts DC. So there is some AC component coming through. It's only halfway rectified, so there is some AC in it, so you expect that. But so the voltage going to that point there is 300 volts, or nearly 400 volts, isn't it? If I do that side instead, that's 411 volts, and that's on that point. The point, where's the other point I'm trying to get to? So that's 400 volts there, which is on the gate. Yeah, so the gate's got 400 volts DC on it. Okay. The drain has got, I'll get onto there because it's the same point. There should be the full input voltage. Let's get on the back. So that's 434 volts on the drain, and the source is 432 volts. So why am I only seeing 54 volts on here? Why is that? Get 432 volts on there. Why is that not doing what I expected to do? That's correct there, but here it's only showing 54. Ah, hold on. It's because I've still got this in line, isn't it? Oh, you damn bastard. There we go. I'll turn it all the way up now, because I forgot that's still in line. We'll try this again then, right? So 376 volts there, and we shall screw this in. See what the voltage does. Yep, it's going right down. Absolutely fine. So yes, I can use a MOSFET. It's dropping down to 9 volts. So I'd say that's probably good enough, actually. So I can do full voltage right down to 9 volts. How regulated it is? Well, it's jumping around a little bit, isn't it? I can still use the same pot, maybe. Or maybe it's a higher resistance. I might have to look at the resistor values I'm using here in order to, because it's creating a divider, kind of, I think. Yeah. It's limiting the current into here. But that is, yeah, 8.6 volts, 8.7 volts. It's jumping around. That's what I'm not liking. In fact, the voltage is jumping. It's not dead stable, and I wanted it more stable than that. I was hoping it'd be a bit more self-regulation going on there. So it's using all the voltage range. I'm getting a big drop through this pot here, so if I get rid of this pot, that'll bring a higher voltage, because the output voltage using this system, you can see even as we're probing it changes it. That's 430 volts, which is exactly what I want. You know, I want 450 or just under, so that's fine. So if I get rid of that pot there, which is dragging it down because it's putting some current loading across it, that's more current available to to test the cap. This current going through the other resistors and stuff, the other networks which I've got in there, and it's using a MOSFET to drive it. So I reckon that'll be good. I don't know if this will need heat sinking. We'll have to just test that and see whether it can freestand or whether it needs to be heat sinked. I'll have to try that out. Put a load on it. Do a test. So it was no worse than before, so it hasn't, you know, negatively affected it. In theory, it should be better than using this pot here. It should be better. So I might disable this pot and go to that circuit there. Now that circuit is working, just use that instead of this pot and see how that behaves and see how much current that can provide without overloading things. It still has to be current limited. It still has to be some kind of limiting in there in order to not overload the resistors, because I've got the resistor dividers and stuff in there, and I've got some current limiting resistors too, really, and I need to be careful that those are not overloaded at all. So as long as it can do the full voltage range, which is what I'm aiming for, and can do the current required, I don't need more than 30 milliamps really. I think 30 milliamps is about the top end of what the circuit can handle with the high voltage. At lower voltages it's fine, it can handle it, but it doesn't need to handle a lot of current. So the high voltage section in here can provide plenty anyway. I'm actually hoping this will mean I've got just enough voltage just using that single doubler stage. So my experimentation with the MOSFET proves that that method does work. However, there are shortcomings. It can't provide as much current as just using a pot. So I'm going to use the pot in my particular circumstance because it's all here, it works. But I was looking for a way of reducing the need to have a high voltage or high wattage pot. So I was just going to use a MOSFET and that did work, and you know, you can always tap it in because it's got the little header pins in there. So you know, that's what I just did, is I just tapped it into those headers. So it's something you could actually fit yourself later on if you really wanted to, or you could do that way instead of the way I've done it. It's easy. The circuits are online, you can get them easy enough. Nothing hard about it. I'll actually probably include it in my information. I'll do the final project summary and stuff like that. You know, as an option of how to do it, because I've got the options are big transformer, small transformers for 12 volt supply, voltage multipliers, or a 12 volt DIN rail supply which can supply the whole thing with 12 volts using a high voltage circuit like this in order to run it instead of all this stuff, and simplify it, and a MOSFET instead of this high wattage pot and things like that. So there's all these different options of how you could build it. I think I'm just laying it all out there and say these are the options at the end of the day, and you can just choose the method you want to use. It's a bit of a tricky one, trying to decide on a final design which everyone can be able to make. So I think maybe having all these different options is going to be helpful to people. It means you have to figure out a few things yourself, just make decisions yourself on how you're going to do it. I mean, if you can get one of these modules, then you're set. You get that. We need a 12 volt supply. You don't need these two transformers. You don't need to build that circuit there. You just need that and a 12 volt supply coming in, and you're set. Right? You could even modify this and use that pot here, that feedback pot, which controls this booster converter. It might be, take that pot off my wires to the front panel and use that pot instead to change the voltage. I think it goes down to 45 volts minimum now. That's the only problem. Might be able to modify the circuit slightly to bring it down lower. I just don't know. It might affect the efficiency of the supply too much. But there's all these different options there. This one works. It does what I want. I've made a couple of little changes here. I put a big high wattage resistor in here, 5 watt resistor. Although I actually think I probably need to change things around a little bit. I've got that series resistor there, which is on the new design. I've got it on the board, but I think I might need to change it to one of those big 5 watt ones as well, because all the current is going through that resistor. I think I need to basically move that resistor here, swap those two around. That one there's really only as a drop for that Zener thing there to help cap the voltage off. But really I think it needs to be over here, or maybe both of them should be these 4K7 5 watt resistors, which gives you a bigger voltage drop, but it limits the current, which is a good thing too. You don't want to overcurrent things and end up things exploding on you. You don't want that either. So this is a 25 turn pot. You don't even need that. You can use a single turn pot, or 10 turn pot even. This is 25 turn, I think. It's just ridiculous, really ridiculously fine control. You don't need that level of fine control. It's a bit much. As long as it can take the current. This one's actually a 100k pot. I'd actually recommend going slightly bigger than that, really. Maybe a 220k, something like that. That would use the current in the pot, but it would also potentially give you a bigger voltage drop and a lower current handling of the system as well. It's just something to bear in mind. This can do 30 milliamps as it is in this state. The MOSFET could do about 22 milliamps, but when you wound the voltage down, because it acts like a resistor, as soon as you put a load on it, it drops more than this pot does. It's only getting sort of 1 milliamp or so at 35 volts. Is only like 1 milliamp max. Well, this can do about 3 or 4 milliamps at the same voltage setting. It just works a lot better because you're going to get voltage drop across the pot, you see, so that's why the current's lower. acts as current limiting, and the MOSFET just seems to current limit further. If you're not worried about having high currents, that low current is fine on the MOSFET. If you want to use it that way, it works. It does the job. But my preferred is this one. This is what I found works best. I've redesigned the board, which isn't in here. I've just redesigned it. I'm going to publish a redesigned board, which has got the changes on it, which I've implemented on this previous board. So it's going to be a new revision with the fine tuning that I've put onto it so far. No doubt people want to do modification stuff to it later on themselves as well. So I'm going to publish the Gerber files, the Eagle files, the Arduino code. I'm going to publish the whole lot on the condition that the header part in the code and stuff and in the files, it states that I'm the author, and it's got this safety warnings and stuff in it too, right? So that must stay in there. If you want to modify it and do what you want with it, that's fine. My name must stay in there as the author. It's pretty simple as that, and a link to my site just to show where it came from. Okay, non-commercial use only. If it's commercial use, not allowed. It's only for public use, you know, individuals, not for commercial. So it's built. As you can see, I've put the front panel on, all the markings. Well, the markings I want to do anyway. I've got it set to, it's doing 430 volts right now. It's calibrated. That's the most this thing can do. It depends on AC line voltage a little bit, but 430 volts is what I've got this thing configured to do at max. And I've got a capacitor here already hooked up, and I've got to change the switch here. I've also changed the resistor on that switch. So it was a 100k resistor. It's now a 10k resistor in order to drain faster. Okay, so I also got this LED now, so it flashes. If I do a charge up, you see the LED's now flashing. And it's all working now. One thing I'm not actually completely happy with, but I haven't actually worked out a way of resolving it yet, is the way the main supply voltage also dips when it's under load. It's not a huge deal, but I prefer it didn't do it. And you can see the current there as it's charging up. This is a 450 volt cap, so it's towards its maximum rating anyway on this voltage. So center off switch. So in the center it will just sit there and the capacitor can drain itself. It does have a little bit of load across the cap, which is from the voltage sensing circuitry, which is through a 4.7 meg resistor and a 47k resistor to make that voltage divider, which the Arduino then reads. So it does have that small load across it, so it will gradually drag that down. It's not completely isolated. I mean, if you want to make that better, you could probably change the resistor values, maybe use a 10 meg or something like that, just to reduce that current draw. You might be able to get a better result, but I'm happy with that. I mean, you can get to see what it's doing. Then of course you've got the drain. This will stay flashing whilst it's above 32 volts. And there's a drain, right? So you just flick it out there and it'll drain that cap out. Right, you can hold it down of course, but I was trying to get it close to that 32 volt threshold to get this to stop flashing. I wanted to see that. There you go, it's really close. You can actually see it's got that absorption effect. You can see the voltage going up. Alright. It'll start coming down again soon, hopefully. I don't want to tap it again, but so that light will stop flashing at 32 volts is where that threshold is for that light flashing. It's starting to drop. As far as I'm concerned, the project is done. I've put the files together. I've put them on the defpom.com website. I've got a link up the top there for projects. Although that site is a mess, I really need to tidy it up and make it better. I've just sort of, when I built it, I sort of threw it together because I did have a proper website. Somehow I lost it. I don't know what that happened. So I've thrown something together and it works, but it's not pretty. So actually I need to go back and fix that site up, actually make it look nice. But there's a link on there for projects, and that's just a page of only one project on it right now, which is this thing, which has a link on it to download all the files for this. So you watch this, it should, there you go, stop flashing at 32 volts. And if I wind this voltage here down, I can probably just go past that threshold again. This multi-turn pot is a bit of a pain. When like a single, I don't know, a 10 turn probably would have been better, but this is what I could find which was doing what I wanted, so charge that back up. This switch is a little bit dodgy. I'm not completely happy with it. I might change it. There you go, so it started flashing at 32 again. So 32 volts. That's just what I've set. It's easy to change it in the code if you really want to. I haven't actually got it as a variable we change normally, but it is further in the code. You can find it. It specifies 32 volts. This is doing what I want it to do. I've achieved the outcome I wanted. I've put some comments and stuff in the files about ways of achieving the voltages and stuff like that. You know, obviously I've used 2 transformers in this particular circuit. Although there was the high voltage board option, which I did show previously, which I've got running around over here still. This board here worked really well. So this is an option as well. I'd be using this rather than transformers because it's a lot cheaper. Current handling capacity is similar. It works perfectly well. You know, if you can get one of these high voltage modules, this one goes 45 through to 390 volts it can do. So it's only slightly lower than what I'm getting on there now, but that can run for 12 volts. It means you can have a safe supply coming in, you know, 12 volt, 15 volt supply, whatever. I think it can run up to 32 volts, I think, is most it can do. Or you can even use a 24 volt supply voltage, actually, if you give it more current. If you use 24 volt supply, for example, this can run off it, and the voltage regulator for the Arduino can also run off 24 volts. So that could be worked. So 12 to 24 volts would be what I'd be saying for voltages, but I'd be inclined to use this instead of two transformers. And then you can make sure you've got nice safe inputs. And you don't have to worry about the earthing and high voltage risk and stuff like that as well. It just makes it a little bit safer. But if you can't get one of these, then just use transformers, it's fine. So yeah, don't forget to check out the stuff. Did I show the splash screen? This is a SparkFun LCD module. Normally has a boot up screen, like it says SparkFun on it normally when it starts up. And there's actually a way of disabling that, so I've actually put that in the code, and it's currently commented out. So if you have a SparkFun serial LCD and you want to get rid of that SparkFun splash, you uncomment it, run it once, comment it back out again, and that splash screen is then gone. But I've got my own one set up in the code here, alright, just for that intro there, for people to know where it came from, what it is basically, alright. But you know, that could be removed by you if you really wanted to, but I prefer it if you didn't. I want to keep that in there. I did put comments in the same, please leave it in. Everything's there, Gerbers, the Eagle files, so you can actually go in and play with the design if you like in Eagle. You can do all that. The Gerber files as my final design, Arduino code, it's all there. Right, and I also got the library for the part I made, which is the Arduino Pro Mini, that footprint. I've already included that library in there as well. So if you don't, it may not like not having that library, so I've included that too. And you can add that Eagle library. So you can add that in as a part. You can use it yourself if you want. I don't care. I'm fine. It's free. Don't worry about it. And I hope you enjoyed the project. Took up a lot more time than I was expecting it to. I've got a usable piece of gear now which can do tests now. I've actually tested it on the part which I actually built this for. Right over here is the parts which I pulled out the Fluke 5200A. This is the part which is leaking. This one here. And I tested it on this and it was leaking at 10 volts. Right. At 10 volts it was starting the bypass. It's drawing a couple of milliamps at 10 volts. Then which way around I connected it up, 10 volts. So that was the issue with that. Because this is running 400 volts across it or something like that. So yeah, that's why it didn't work properly. So yes, this tested on that part which I built it for, and that confirmed, yep, I've got a problem with that part. It does what I want. Don't forget to subscribe, click the bell icon, tell your friends, share this video, share this project. I'll be linking the video series all together in the description down below. I'll check the links in down there. I'll also link down to my site as well, where the files will be for the project. You can buy the Arduinos through Banggood. Use the Banggood link in my description. Buy them through there, because then I'll get a credit onto my account with Banggood. Doesn't cost you anymore. Helps me get some extra credit on my account, and it helps me to buy things cheaper. So, right. Thanks a lot. Catch you later. Have a good one.